Hey everyone, in this lesson we're going to be talking about some of the nuggets of goodness that the E6B is capable of doing. That's some of the things that you might not use day to day or on a written exam, but are maybe a little bit helpful just if you think about using the E6B to do these problems. For our first nugget of goodness, we're going to be taking a climb gradient given to us in feet per nautical mile, such as one that you might find on an instrument departure procedure, and we're going to turn that into a feet per minute climb rate. So, for those of you with no background, if you are flying an instrument departure procedure, there's usually a climb requirement, and they don't give it to you in feet per minute, they give it to you in feet per nautical mile, because as your ground speed changes, so does the required climb rate in feet per minute. So for this question, we're going to be referring to a written out ODP and a written question that goes like this. In order to fly the ODP at Wannabe Airfield, what is the required rate of climb if the ground speed is 90 knots? And then we have a little snapshot of the actual ODP there. It says takeoff minimums and obstacle departure procedures, and it says the takeoff minimums are standard with a minimum climb of 300 feet per nautical mile to 2,000. So, if they want us to maintain a climb gradient of 300 feet per nautical mile up to 2,000 and our ground speed is 90 knots, what is that in feet per minute? Doing this on the E6B is not particularly difficult. Take the rate arrow and set your ground speed on top of it. On the inner scale, find the feet per nautical mile climb gradient of 300 represented by the 30, and on top of it on the outer scale, read feet per minute. We now know that 300 feet per nautical mile equates to 450 feet per minute when we're doing 90 knots on the climb out for this departure. The next little nugget of goodness is making course corrections with the E6B. Let's say that you are making a cross-country flight and you find yourself a little bit off course. You can use the E6B to figure out what intercept course you should be flying. Here's a sample written question that we can use the E6B to solve using that concept. You're making a cross-country flight from Lewiston Airport to Moses Lake. After going 50 miles, you realize you are 6 miles off course. How many degrees of course correction is required to rejoin the original course if the remaining distance is 55 miles? Questions like this are usually accompanied by a figure to show you what the flight plan looks like. I've included one with some measurements that I just took off of ForeFlight so you can kind of see the overview of what this flight actually looks like. You don't actually need to know what the flight looks like in order to do this on the E6B though. So let's get started with how to put it into the E6B. First, I want to point out that the instructions on how to do this are on the insert at the very top of mine, as you can see here in this clip. But let's jump down to the slide rule so we can actually start working it out. The first step is on the inner scale. Find how many miles that you've traveled. In our case, that's 50. So we'll find that on the inner scale and rotate it until it matches the distance off course on the outer scale, which is 6 miles. Now that we've got that set up, we can read under the rate arrow a correction that would parallel the course that we had originally desired. In this case, you can see that a course correction of 7.2 degrees is required in order to parallel our desired course. The next step is to figure out how much additional course correction is required to get us back on course. The way we do this is take the remaining distance of 55 miles on the inner scale and match it up with how far off course we were on the outer scale. So we're going to take the 55 and rotate it until it's underneath the 60. Now we can see that we need to add another 6.6 degrees in order to correct back to course. We should get a total correction of 13.8 degrees back in the direction towards our course. For our final example, we're going to be using the crosswind tables on the E6B Insert to figure out what the crosswind component and headwind components of the advertised wind on the ATIS is. Here's the ATIS from Renton Airport.
Renton ATIS information Alpha 2053 Zulu. Wind 190 at 20. Visibility 10. Sky clear. Temperature 21. Dew point 10. Altimeter 3007. Landing and departing runway 16. Advise you have Alpha.
So the ATIS says they're using runway 16 and the winds are 190 at 20. There are two different charts on the E6B Insert that we can use to determine the headwind and crosswind. The first one we're going to demonstrate is the wind component grid. You probably recognize this, it's in a few POHs and it will show up on the written exam, but it's also a very useful tool if it's really gusty and you want to know how close to the crosswind component we are. In order to use the wind component grid, we need to figure out what the difference between runway heading and the wind direction is. We know that we're using 1/6, which means the runway heading is roughly 160 degrees, and the winds are from 190, and that's a difference of 30 degrees. So locate the 30-degree line towards the outside of the grid. Once you've located the 30-degree line, follow it inwards until it intersects the 20-knot arc. From the point where the 30-degree line intersects the 20-knot arc, draw lines straight down and straight across to find the headwind component on the left and the crosswind component on the right. You should find that there's a crosswind component of 10 knots and a headwind component of 17 knots. The second way we can do this problem is by using the crosswind correction chart at the bottom of the E6B insert. On the top you can see the angle between the wind direction and the true course, and on the left you can see the wind speed in knots. We've previously discussed that there's a 30-degree difference between the wind direction and the runway, and the wind speed was 20. You can use this just like a performance chart, follow the 30-degree line down until it intersects the 20-knot column, and you will see that there is a 10-knot crosswind and a 17-knot headwind. Now that we've covered all the things you need to know about the slide rule side of the E6B for the FAA written and for the practical test, let's move on to the wind correction side.